I made it. Hello, everyone. Thank you all for joining us for this month's AusIOT. I don't know why I paused just then. That was weird.
You're
Anyway,
not sure where you are. You've been on enough things today.
literally just refreshed the browser and made it back in. But hello, everyone. Thank you all for joining us. And hello, Michelle.
Hi, developer Steve. How you going?
Good. I should do the screen sharing thing.
And by the way, everyone know this is not a virtual background. This is my real bookshelf, color coordinated. So
Wait, this is real too, though.
yeah,
Joking.
it's like what is real actually? Like
It's been raining
real.
so much out here today. This is what happens. So hello everyone, let me switch to my slide deck view. There we go. Hello everyone and welcome to September version of AusIOT. We have some amazing talks lined up tonight and really excited for those. And as always, just to geek out and do all the things. But first, we have the acknowledgement of country. Michelle, did you want to do that one?
Yeah, for sure. So it's funny, I've actually been trying to connect to South Australia a lot lately since I moved back during COVID. And I found that my family has actually lived in South Australia for 8 generations. And I was like, oh my God, that's such a long time. That's so fantastic. That's a long time. And then obviously I realized that's nothing compared to the 60,000 years of people that have been living here before us. So even though I've been here for a while, I always like to pay my respects to the Kaurna people, who are the First Nations on this land where I'm dialing in from Adelaide today. And I extend that respect to all of the lands you guys are meeting on today, whether that's in Australia or wherever. Yeah. What about you, developer Steve? What land are you dialing in from today?
I'm in Wagunda, which is out in Narromine, out in country New South Wales.
Oh, lovely. Oh, that's cool. And if you guys know what land you're on, please post it in the chat. If you don't know, quickly Google it and make sure you know where you are.
Cool. Yeah, please drop that in the chat. I always love seeing the different lands that people are from. So we have for the agenda for this meetup, we have we're going to do some news and events. Actually, we have a lot of news items in this one. It's gonna be fun.
Yes.
And then we've got first talk, which will be diversity, development, and disruption by Ami from Telstra. Ami is amazing. And then we have Luke Jackson talking about one of my favorites, Sumobots. I don't know if anyone's familiar with Sumobots and all the fun ways that you can build them, but yeah, that's going to be a really cool talk.
I had to Google it first. Like when you said we're doing Sumobots, I Googled it and I watched a lot of videos and they had Luke's videos on there. And so now I'm very excited.
Nice. Yeah, I've been to some of the Sumobot days before. A lot of the Makerspaces will do like this one day where everyone can go in and make them and battle them to see, well, one Sumobot to rule them all, so to speak. I feel I should have a Lord of the Rings background for that. But anyway, yeah. But for those that aren't familiar with the venue, this is Remo. This is the virtual venue we've been using for the meetups. So pretty easy to navigate. You're currently in presentation mode, so everyone's in the one space. Please use so on the right-hand side of the screen, you'll see a chat function. So there's a main chat. Special tip on that too, marquee works. HTML tags work, but in particular marquee, which is, well, it's one of my favorites. For those that remember marquee, makes nice scrolling text. And then there's a Q&A section as well. So if you have any questions during the talks, either put it into the main chat, we'll keep an eye on that and just copy it over to the Q&A section, or you can just put it into the Q&A section and then we'll ask once the presenters finish presenting. Yeah, it's a word.
We haven't mentioned this yet actually too, but this session is being recorded as well. So we're putting it up on YouTube for you to watch later, or people that couldn't make it today. Or if you just love the talk so much you want to rewatch them, then you can go back on YouTube. We actually have all of our past talks on there as well from over a year ago, which is crazy to think we've been doing this for over a year. But
I know, right? It's on be 2 years soon. Where did this year go? It just evaporated. We do have a code of conduct. Essentially, well, the way I always like to think is just be excellent to each other, because I mean that's what open source is all about, right? But yeah, we promote inclusive, diverse, respectful, and friendly communities. So if you want to check out the code of conduct, links on the screen. Actually, I think we need to update that to AusIOT. And also there's a QR code there too.
Actually, since our last talk, I actually went and looked at the code of conduct. You know, I feel like I've been doing this for a while. I'm like, oh yeah, I better go refresh and see what it was all about when I joined. And it's fun because it's not just about not being bad to each other. It's about actively being excellent and inclusive and friendly and great. So I love that this is part of our community. So thank you guys for all accepting that by joining and being part of it.
That's the thing I love most about open source communities and meetups is everyone's just willing to share and learn together, which, I mean, that's what it's all about, right? We're all products of open source now.
Indeed.
Also, so the Thankyou host sponsors, IBM, Telstra Dev, and Sneak, just for contributing time, resources to making this happen, the amazing venue, etc.
Yeah, before you go off that slide, actually, we haven't introduced ourselves because I feel like we do this meetup very often, but we never introduce ourselves. So I'm Michelle Howie. I'm a developer advocate for Telstra Dev. And I'm a developer advocate because I think that it's really important that lots of people should know about technology and how to actually use it. And I think that's one of the reasons why we're doing this whole meetup and why you guys are here too, because you want to learn how to use technology and be part of it. So that's what I do, and that's me.
I'm glad you mentioned that because I didn't even think about it. But hello, I'm developer Steve. I'm one of the developer advocates at Sneak. And same thing, yeah, I just love helping bring community together and just get all that sharing. And well, I always think of these as geek out sessions. And like I've been writing code for a long time, since the age of 8. QBasic, if anyone remembers QBasic, like pop that in the chat because I'm surprised about how many folks actually started coding with that back in the day. Anyway,
we also have developer Ali from IBM who is in the chat posting amazing links for us, and we usually rotate the host, so it's her turn to sit on mute and eat while we're talking.
TRS 80, yeah, I remember that one.
Actually,
there's Ali. Hey, Ali.
There she goes.
Anyway, Vince will geek out about that later. Otherwise, I'm going to get distracted. Anyway, let's do the news and cool stuff and then get on to the first talk. So we found some interesting stuff this month. In particular, there's a lot of rising vulnerabilities now appearing in firmware and also IoT hardware. So this is a really good write-up on Hackaday about Bluetooth vulnerability that is now on ESP32. I mean, it was a matter of time. Those things are literally candy now, like literally candy. But yeah, check that out.
Don't eat them, please.
Don't eat them. we don't. This is a good point. We don't condone the eating of IoT anythings. But yeah, the Bluetooth vulnerability is a little bit scary because it basically allows an attacker, well, to be able to take over your devices. And like one thing we saw last year, this still like blows my mind that somebody would hijack a whole bunch of IoT, in particular Cat-M1 devices, to download manga. So apparently that's a thing. Well, it was last year, but this is why we need to keep these things protected and make sure the firmware is secure and the devices are secure, so no one does anything nasty on there. The last thing you want, and this is probably unlikely, but the last thing you want is someone mining Doge on it. Just you don't want that, or just hijacking in general. This was actually in the last day. This new. I want to say it's a new 3D printing technique, but anyone that's familiar with 3D printing, it will know like you can basically print very flexible plastics pretty easily. In fact, when you're printing supports for a model, quite often these little springy bits that you see in this GIF here, like you'll actually get those printed around the edge. And I've often looked at them thinking, oh, you could probably use that for something. So it turns out someone has. Essentially, they've made these little switches and interactable devices. So what's happening here is the bits in the middle of that spring push are basically creating a contact between two plates, and you've got a switch, which is kind of cool. I actually need to try doing this because they could have some fun like uses. But there's a full write-up on that too, and also. This isn't really IoT, it kind of is, but I just found this interesting. Netflix actually use MQTT. Kind of makes sense, but especially at the scale that they would probably be using it at. But yeah, I just found this one super interesting that they're using.
Oh, sorry.
Essentially, they're in-platform communications between like likes and any sort of interaction on the platform side of things, from what I can tell. But yeah, it was super interesting that they're using something like MQTT at like massive scale. And anyone that's read their server architecture behind all that as well is like, it's crazy the amount of traffic that they handle. Anyway, I just found that an interesting write up, and it's kind of IoT related, especially given that IoT's early days, it was literally used to talk to monitor oil pipelines from space. So now it's being used for entertainment industry. Second last thing, the H7 Potenta Lite is now available. Actually, Michelle, you've played with one of these, or you've seen
I haven't
one?
got one yet. Like I've been using, let me get out my drawer of goodies. I've been using the NKR NB1500s, which is
Oh, yeah.
The narrowband IoT like Arduino boards. This one is cool, and I'm excited about it because of the onboard AI capabilities. And I've been trying to get some stock from Arduino because apparently they're getting an narrowband IoT like add-on as well. So they could do like Bluetooth and Wi-Fi, but you could get a like add-on to get it to do narrowband IoT, which is the SIM one. Very low stocks. Like I have been struggling, but they said they're making more. So what do you know about the H7?
The chip shortage.
Yeah,
no doubt.
so.
The TensorFlow Lite I found super interesting. The fact that it can run that now, which kind of opens up, because this is the light industrial play, or the almost like the entry level or the prototyping industrial play for Arduino. So the TensorFlow component alone kind of opens up some interesting opportunities, I think, for industrial side of things. Do you think like production lines and any sort of industrial machinery interactions? Like, yeah, that's super interesting. Also, you can run MicroPython and JavaScript via an interpreter on the actual board itself, because it's a dual core Cortex M7, essentially running at 480 hertz and an M4 running at 240 hertz. I totally didn't read any of that from the slide notes. It's a lot of numbers. No, I actually did.
We're not sponsored by Arduino, by the way, but we do love them. And we did have Massimo from Arduino. He's the like Australian like business Arduino guy. He spoke at our Brisbane meetup a few months ago, which we've got the recording of that on YouTube. And this actually came up in our Discord chat the other day. So someone was prototyping something with their Arduino board, like one of our IoT community members. And they were like, hey, look, this is really cool, but where do I go like for the next step? Like what's the next one? And so this is kind of Arduino's answer for the next step. So it's still like a prototyping board, but it's kind of industrialized as well. So you can sort of use it for more like production use cases. So I haven't used it myself yet though, but.
The next step up from this, the Potenta 2, I saw on, I think it was an Arduino. Actually, I think Massimo posted it, that the Docker images are now supported on the full-blown Potenta as well. So yeah, interesting times. The containerization at edge with IoT stuff, super interesting.
Yeah. Edge. I could talk about Edge all day, actually. I think our first AusIOT meetup, I talked about 5G and IoT. I reckon we do for an Edge talk. But I see Ali has put in the YouTube videos for Massimo's Arduino chat. So thank you for that.
Thanks, Ali.
And thank you for all the other links you put in as well.
Last one is Microsoft actually put out a nice little course free for everyone on IoT stuff, or IoT for beginners. It's they've got a full GitHub repo basically stepping through everything you need to know to get started with IoT, which is kind of cool. So yeah, check that one out, particularly if you're looking to get started. Maybe you can combine it with some Sumobots. That's always fun.
Yeah, I always find these things are good too. Like even if you've done IoT stuff before, it's always good. It looks pretty friendly. Like it's not a university course. It's funny because I did electronics engineering at university and we didn't learn IoT wasn't on the curriculum at all. It's like, surely you do electronics, IoT. No, so you got to teach yourself this stuff, I guess.
I think it's interesting seeing the IoT companies now to create that pathway of like making a tinkerable Sumobot, for example, and then taking the same skill set up to building a full-blown production line.
Yeah, good point.
All right, let me switch to the next one.
Our favorite. So we've talked about Discord a few times. If you haven't had the pleasure to join our Discord community channel, please do. This is actually the only Discord channel that I'm part of at the moment. So I love going through the IoT related stuff. So I guess this community, this AusIOT community, is about enthusiasts for IoT. And we found that people, of course, during these talks and these guest speakers, we learn a lot. But in between the monthly catch-ups, like there's a lot of questions that come up with people actually doing IoT for their personal or professional use. And so we've had a lot of engagement in there. So I encourage you guys to join. If you're a beginner, you can get help from some of the best IoT peeps in Australia. And if you're an expert, there's lots of things that you can help with in the chat. And I think all the new IoT news that Developer Steve just went through, like we post stuff like that all the time. So welcome you to share your IoT news if you see something that we should be talking about.
We actually created a whole new channel because everyone was talking agri-tech, so there was an agri-tech channel as well.
Agri-tech channel. I think I started a South Australian IoT channel because I'm an SA and always feel lonely. So Ali just said we've got 76 members in the Discord now, so keen to see that grow. Also, before we go to the first chat, Ami is a very busy lady. She's senior, solution architect for IoT and Cloud. She's running a bit late, so there she's here. Okay, we're just going to say Luke can go first, so we can skip through there. But also, guys, I've got a vaccine today, so I thought I'd just say that I got my first vax. I just saw myself in the video. I'm like, what is that on my arm? Oh, I forgot to take my band-aid off. Sorry, guys.
Well done. Cool. Should we move on to the talks?
Yes, absolutely. Good. And we can get Luke to come up first, I reckon. Okay,
cool. Let's skip some slides. I think I went too far. Yeah, I went too far. All right, there we go. Yay. All right. Luke Jackson. So Luke's a Makerspace ambassador. And if anyone hasn't been to a Makerspace yet, actually, that might be a little bit tricky at the moment. But if you get the chance to go along to a Makerspace, like I always love Makerspaces. I've been to them in any country that I've passed through just to be able to drop in and see whatever geeky projects they're building. I once walked into the one in Footscray and there was a full-sized wearable mech suit there. Whole other story. Anyway, Makerspaces are great. So please support them where you can as well. But Luke's also the secretary for the UNSW Mechatronics Society. They also do amazing work too, and always doing all sorts of fun tinkery projects. But Luke's here today to talk about one of my favorite topics, which is Sumobots. Hey, there he is there.
Hello. Hey, everyone.
Hello. Welcome, Luke.
Thank you. All right, let me share my screen.
So if anyone has any questions to ask along the way or comments, drop them into the main chat or into the Q&A section. Well, questions into the Q&A section, obviously, but cool. Let me stop sharing screen.
All right.
There you go.
Perfect. Cool. All right. So yes, my name is Luke. Thank you for the intro, Michelle and Steve there. So I am a student at UNSW studying mechatronic engineering and computer science. I'm currently in my 4th year. But a lot of what I talk about today will be going back to my 1st year, which is where I actually went into the Sumobot competition for the first time. So first of all, I'll just talk about the Mechatronics Society a little bit because they pop out throughout this quite a bit. So I am the secretary as part of it. And basically what it does, it's where all the cohort of mechatronics students at UNSW can come together, talk about coursework, talk about projects, anything mechatronics related. That's what we love to see. And for example, we run competitions. So Sumobots is probably one of the main ones that we run just because it stretches so, it can start so easy from that 1st year because you don't need many skills to get into it. And we guide those students through from the beginning. Whereas 4th years, they can extend it so far. So they can put on rotating ultrasonic sensors that can look all the way around, whereas the 1st year might just have the bot rotate its whole body. So you can really extend it from that easy stage to the really complex. We're also trying to get a micro mouse competition happening. So it's like a little robot that goes and maps out a maze, and then it tries to find the most efficient way from the beginning to the goal point. So I highly recommend looking that up on YouTube because it's super interesting. But I also just love making projects, and you'll probably see some of them pop up in this presentation a little bit later as well. So what I'll start with is the Makerspace. So I also work at the Makerspace at uni. And it's pretty interesting that we've got the students actually working at the Makerspace. We have full-time staff who are a lot older than us actually looking on, but our entire staffing casual network are all students at UNSW. And that's what I really love. I'm working with people who are studying mostly engineering, but sometimes design or even arts. And basically, we just all love making stuff. So we get to roam around in this Makerspace, help other students, help researchers, that kind of thing. And we've got all these tools available. So we've got all the wood metalworking tools. What you see here is the James and Kirby Makerspace, one of the engineering makerspaces at UNSW. So we've got all wood and metalworking tools in there. We've got laser cutters for cutting plastics, woods. We even have a metal laser cutter that's pretty new as well, and that's really fun to play with. We got something like 20 3D printers in one room that we can just play around with, print what we need. We've got electronic stations, soldering irons, hot air guns, all that kind of good stuff. Machines. So this kind of builds an idea of what we have available for those students to actually build those robots, not just Sumobots, but also throughout their entire degree. They can build whatever they want, basically. So mostly coursework happens in here. We have one first-year course called Eng 1000, where it's split up into different streams, but the whole makerspace gets filled with them building sometimes like cardboard arms to go and pick up objects, little cars to go around a maze. That's one of the other projects that they can choose. So it's really interesting seeing all these first years or second years coming in and starting there. And we try to encourage them to stay, come back, doing coursework or even personal projects as well. We'd love to see that. So I'll start to get a bit more into the Sumobot side. So let's have a look at the professionals. So this is like the end goal. This is the level that it's pretty hard to reach, to be honest, at especially at a student engineering stage. But these guys, they've got a full metal base, and the robots they basically magnetically stick down to get extra grip. And you'll see now how quickly they can go. So I'm hoping that video comes through. There's no audio, so don't stress about that not coming through. But you can see now the kind of speeds that they run at. And you'll notice that there's a white ring around the outside. That's purposeful because the robot wants to try to detect if it's going outside of the ring and pull back in so that it doesn't actually go out. So the rules of Sumobots is basically you're trying to knock the other robot out of the ring, or you're trying to, if they don't move for 5 seconds as well. But on the professional level, that's pretty rare because there's less breakdowns happening. Seeing the end goal state, we'll start to get a bit more into what we do in the Mechatronics Society competition. So this is way back to my first year. This was literally within the first 4 weeks of coming to uni. Very little experience with electronics, programming, everything in high school. So it was quite a step for me to come into this. But honestly, it is the greatest thing I've ever done. And it's pulled my path into making projects throughout the whole of my degree at uni. So as you can see here, we don't have a metal base, but we've basically just got a cardboard surface there. Actually, no, sorry, it was MDF, but we still got that white ring around the outside that we painted. So the robot knows when it's going outside. And you can see everybody standing back. That's because all the robots have ultrasonic sensors on to read if they see another robot in front of them. So we want everyone to stand back so that they don't interfere with anything. So we did it a round robin style, this competition, and it's best of 5 rounds in the ring against the other robot. The robots start at different angles, so you can't just program it to instantly turn around and go forwards to round them. It could start facing on the outside of the ring, facing inwards, facing right, left, or an awkward angle, anything like that. So you had to make it adapt to what it was in at the moment. So here you can start to see some of the designs that some of the other teams came up with. So in here you can see there's ones that are acrylic. So the one on the far left is acrylic, clear acrylic. Then you've got some ones that are wood as well. And those acrylic and wood, they've been laser cut. You've also got a 3D printed one at the bottom of the screen. And kind of one that's being just cut up on the bandsaw, made out of full wood underneath the white text area. We even had one that was made of cardboard. It was a little bit flimsy, I'll say, but it was honestly pretty cool to see because it did actually move around and everything. It didn't win any because there wasn't enough force or weight behind it, but it was pretty funny to see that. But it was really interesting as well, actually seeing all the different designs come out at the end. And pretty much the rules that we had to follow for building, we had a lot of free roam with the design. All we had to do was fit within a 200 millimeter cube, which is basically what the distance between the wheels was when you've got the motors set up end to end. You had to make it weigh 1 kilogram or under. So ideally, you want to try to put as much weight in as possible so you can get that friction onto the floor, because we noticed pretty quickly that that was the depth. All of the designs is the wheels would slip pretty frequently. So the more weight you can get, the better it would work. When you press the button on it, had to wait 3 seconds before actually starting so that you could vacate the ring and the robot could go out and do its thing. And this was the first time that we ran Sumobots, and the uni had no idea what it was. So they thought that we were bringing out the battle bots, that we were swinging swords or something around. So we had to convince them a lot that it was going to be safe, that it was literally just robots pushing each other, just bumping in. And eventually we got past it and we got to have the competition, which was great to see. So throughout the whole design period, so basically the competition went on for about 8 weeks. We had different workshops where students could come in, and especially for me, I didn't know a lot of the electronics or coding or CAD or anything like that. They would teach that all throughout. So we started out nice and easy with just sketch up a design, and then we'd go and do like how to CAD 2D, how to CAD 3D, how to program Arduino, how to wire everything up. And that was great because it started out nice and easy. And that's what I love about this competition, is that those first year students can enter this and still be guided very nicely through. It's not a difficult one to work with, but you can extend it so far if you do want to push yourself. That's what I love about this. So I'll show you a quick video as well. So the plastic one on the acrylic one on the right is the practice one that you could go up against, that the person running the event created. And the one on the left is one of the other student teams' bot. So you can see that they're facing at opposite directions. They start off and they're basically just trying to look for each other. They've got a sensor that goes out and tries to see if there's anything in the way. And if there is, then it's basically just going to try ram for it. So you can see the student team's one is winning at the moment. It's got a little bit more force. The video ends before we actually get to see who wins, but I think we all know who the winner is there. Student beats the teacher. All right. I'll also run through some of the components as well, because I want to show how easy it is, basically. So this was the first time that I'd used an Arduino, and since then, I can't even count the number of times I've used it, because it's just so easy, so accessible, and I love them for all my projects. So we had an Arduino Nano, but honestly, any Arduino would work for this because it's just such simple code. There's not many connections that you need. So we just had one of these. We had a nice, easy motor driver. This is one of the most common ones that you could find. And this was just to drive those DC motors. And those are the DC motor kits that we had. So you'll be able to find these online if you want to build your own Sumobot at home. And it came with the tire, the bracket, and everything that we needed. Ultrasonic sensors. These are the ones that actually detect if there's something in front of it. So they send out a very high frequency signal, basically like a bat. So it sends out that signal, it bounces off a wall and comes back. And since we know how fast the sound is traveling due to the speed of sound, we can calculate how far away something is. So you can get rid of stuff that is too far away. You can check if it's actually like consistently there. So you can try track an object or anything like that. So it's really cool, the kind of extension that you can do with these guys. You can have it rotating freely on the Sumobot and make that another way to actually track down the other bots to go in for the kill. We have IR sensors as well. So these commonly sit under the bot, and these are the things that actually detect that white border around the ring, basically telling the bot if it's going to go outside the ring. And then the code will say, hey, I'm going outside. I'm going to pull myself back in to save myself. So depending on what strategy you wanted, you might have your bot circling the outside of the ring, looking for the competitor, or you might have it going to the middle and just spinning around. There's many different ways, but this helps you to actually stay within that ring. We had a nice simple LiPo battery to actually power it, and of course the start button as well. So here's like the wiring that we came up with. And for people who maybe haven't seen diagrams like this before, it may look complicated, but honestly, it's as easy as like connecting one point to another. It was so nice and simple. And we used a bunch of jumper cables that are common with Arduino. You'll see it if you look up Arduino kit anywhere online, it always comes with these. Super, super simple, because we wanted to reduce the number of soldering points to make sure that students aren't going to break their Arduino or have to solder and then desolder and then solder and then desolder their components, which would be absolute nightmare a lot of the time. So we tried to make things as simple as possible. And that's why we use these jumper wires. And you'll see in a minute how crazy the wiring gets because of this, but it does make the actual connections nice and easy. So for the competition itself, it was pretty strict on the components that you could use. So you couldn't swap out the motors. You couldn't, there wasn't really much point swapping out the Arduino or anything. You couldn't add many sensors. You could add a servo if you wanted to actually do that searching around, rotating of the ultrasonic sensor on the robot. That was allowed because we wanted to have some creativity. So we wanted to make people try push it, but we didn't want to make it unfair for people. And that was a really interesting one that I think only one team actually managed to get going with that searching around. And it didn't necessarily make them above the rest or anything like that. So it's pretty interesting to see some of the designs. Some teams could also double up on the sensors. So some teams had a couple of ultrasonic or a couple of IR infrared sensors. And those were within the rules as well. That was no stress at all. So yeah, this was the design that myself and my team came up with. So we had a flat wooden base on the bottom. And what I wanted to do was kind of mess around with a bunch of different curves and everything, because I wanted to try get under the robot. That was my whole strategy plan, was if I can get under and lift their wheel up at least just a little bit off the track, all of their traction disappears, and then we can come in and take them out. So I tried to make it very modular, and pretty much the 3D printed outside, I could swap that within a few seconds because there was just 4 connection points, and then they slide off from that wooden base. But you can start to see a little bit of that crazy wiring that I was talking about. Pretty much all the bots had that. There was nothing that you could do against it. But once you got it wired up, you didn't really have to switch it around or anything. So there's no issues there. So I've got that nice little curve, 3D printed curve that goes to the base. This turned out to be a little bit of an issue because the MDF surface that we're playing on wasn't actually completely flat. There were little bumps in it. And because I had built mine very, very close to the ground with only a tiny little bit of that wheel actually like below the bot itself, there were times when it got caught and it would just get stuck on the edge and the other bot could come in and take us out. But honestly, it was a lot of fun making this robot. So I was the one on the design side, the mechanical side. I had 2 other teammates as well who worked on code and electronics. We had a little bit of issue with a couple of sections in this, but it was still all good in the end. So I'll show you some of the actual competitions with our bot. So the night before, we had some issues with the programming where we had to completely kind of scrap it and just do like a last minute. So pretty much what I could whip out was have the robot spin around until it sees another bot and then just ram forward. So turns out this is actually one of the best options. So I'll show you some of the videos. If you see our bot up against this clear plastic one, that's the ones from the finals. Their bot unfortunately had a few issues in the finals where their button didn't actually work. So you'll see him kind of press play and then put it down and hover there for a minute. That's just because he was trying to line up the timing the same as ours. So there are a few delays there, but hope you enjoy these. This was one of the teams that had probably one of the better designs that was really quite hard to go against. I think it came to, they won 2 of them and we won 3, but it honestly came to that final one where it was 2 each and we just managed to scrape that last one. So honestly, their bot was real tough to work against, but you can see the kind of competition we had. We had heaps of people involved, which was great to see. There was probably, I think there was around about 15 teams that actually managed to create robots. So it's really great to see so much involvement in this. And this brings us to when we tried to run one this year. So this was in that kind of weird state between the 2 COVID lockdowns. We thought we were good to go. We set everything up. We bought all of the components that we could give out to other students, and we managed to have about 3 or 4 weeks of actual workshops, design, some programming, CAD, that kind of thing. And then suddenly COVID hits, get locked down, and the competition was unfortunately cancelled. But you can see here the kind of turnout we had. I think we had something like 40 teams for this one. So it really massively escalated from when I first did it in first year. So I was really happy to be involved with the society itself and actually helping to run it this time. So I'm hoping that sometime maybe next year, we can actually get this up and running again, along with possibly like the micro mouse that I was talking about as well, to extend some of those 3rd, 4th year students who want to take things just a little bit further as well. If anyone actually does want to do Sumobots as well, I know a lot of Makerspaces, they do those Arduino ones, as Steve was saying before. Sometimes they also do the Lego Mindstorms Sumobots as well. And that's really good for those primary school students where you don't need a lot of that. You don't need to actually physically make it out of wood or plastic or do proper wiring. It's nice plug and play and all those little blocks on Mindstorms. So I highly recommend having a look up. And if you have some Makerspace around you or some way of playing with the Mindstorms, I highly recommend Sumobots. It's a nice way to get students involved and learning from a young age as well, which is great. I'll go on a bit of a tangent as well now, because I've used Arduino heaps since this, and I feel like it's a good place to kind of geek out and show off some of the other stuff that I've done with an Arduino. I'll keep it within the boundaries somewhat, at least. So here are some of the other projects that I have worked on, either as a student project at uni or just in my own free time. So this one in the top right was a LED costume that I made for a friend's party. And pretty much I just had an array of LEDs on the shirt, and I programmed it with a bunch of different animations. I also made one where it reacts to music as well. I've removed the music from the video so you guys don't get copyrighted, but it's literally just running off an Arduino, and you're able to get all these cool animations. It would listen to music that's happening in the room and react in time with it. So that was really, really fun to play with. I also had like a little PCB heart as well that I stitched up there that would animate too. But I was really quite proud of that one, doing that in my own free time. And then in the bottom left here, I was involved with UNSW Illuminate, which is the student-led society, student-led project, where we enter into Vivid, the Sydney Light Festival. So once a year, other than when COVID's on, people can walk around the Sydney Harbour and see all of these lighting installations. And so the UNSW team were in it for about 3 years, and I was able to help out on one of the projects. I took on the role of the electrical lead, and this is one of the panels that was on an 8-meter disc that you'll see in the video. This is only half of one of the 7 panels that was on the full disc. So it's about an 8-meter disc in total. And we had some little plastic optics as well hanging down to give it some texture. So you'll see that in the video here. So we ran some tests through it and everything. It was all a wood backing. So that is about 8 meters in diameter. And we had some speakers going with some nice music in the background. Whole bunch of animations running throughout the nights because Vivid runs for something like a month. So we had to come up with different animations constantly and make it really enticing for people to come over and just stand under it, stare upwards and see all the lights. So that I learned a lot from that. And from that, I was able to take it to my next project, which I was still involved with UNSW Illuminate, but I stepped up to be the technical director. And I was involved with creating a laneway installation for UNSW. And so I decided to have some stars hanging along the laneway with some LEDs in it that we could program with animations and everything. So had to bring it home because COVID shut it down a little bit. But while I was working on it, this is what my house looked like. And we're able to get some, it doesn't show too many animations here, but this was the testing. So all the stars clumped together hanging down, and then it switches to the actual laneway. I filmed this during the day, so you can't see the lights too much, but during night, it really lights up that laneway. And as you walk down it, the animations zigzagging back and forth, randomly lighting up stars and everything like that. And I was super proud of that. But all this stuff is running off Arduino. The one in the bottom left, the Vivid one, it doesn't run off an Arduino directly. It runs off something called a Teensy, which is basically, it's built with almost, it still runs with the same Arduino programming, but it's a little bit of a faster chip. So it can actually run through all these bigger animations just a little bit better. Same with the one in the bottom right as well. We wanted to make sure that there were no issues with lag or anything. So we used a Teensy. And I highly recommend checking out Teensys if you are looking for that Arduino, but with a little bit more power as well. They're really nice to work with. Let me skip on. There we go. So that's about it. I hope you guys have enjoyed it. I hope you got the idea of how easy the Sumobots is to get involved with. If you ever want to actually build one yourself, I highly recommend looking up on Google because they're everywhere. Instructables has great tutorials, YouTube as well, and it's a really nice way to get involved, get started. As soon as you get started, you're able to build up to all of these other projects and stuff with still Arduino, all the stuff that you've learned before. So if you ever want to contact us at the Mechatronics Society, email is right there. Also highly recommend Facebook and LinkedIn. You'll get to see all of the student projects and workshops and stuff that we run put up there. And you can also email myself if you have any queries about anything. And my LinkedIn as well. I post a bunch of stuff as I go along too. It looks like I have 4 minutes left, so I've got time to show you one more project. I had this one just in case. I had a little bit more time. So I was also involved with flight labs at UNSW, where we built autonomous drones to fly around, take pictures of the ground, locate certain artifacts, certain shapes and colors on the ground. But the area that I was involved with was a little car that would be dropped down from this drone and then go out and navigate its own waypoint mission. So you'll see in the bottom right here, that car running out. And this is all running autonomously. This doesn't actually use an Arduino. This is something called Pixhawk, but it's still interesting to see some of the other projects that I've been able to work on because of my knowledge that I've built up basically from an Arduino and how much I've loved them. Perfect. And that is everything.
3 minutes for questions. Easy.
Yeah. Any questions, anyone?
Oh, I got so many. Anyway, that last one. So funny story. Like I've done a lot of conferences in my time, and I always love coming up with crazy ideas. So this one time for a certain IBM company, I may have suggested we do a IoT triathlon of sorts, where we drone something in through a maze and then drop a car, and it would go through and then go through water. Like, if you want to do something like that, please let me know because I'm keen.
Okay. Yeah.
I thought you were going to say about the time at Telstra when you tried to make an IoT t-shirt and then you succeeded, but then set yourself on fire.
Oh no, that was a PayPal. I was getting to that.
Oh.
But yeah, actually, I did have a question. I put a question in the Q&A about that. Is with I built a few T-shirts in my time. Yeah, and fun fact, on my Flickr, there was one time one caught fire. Anyway, what did you use to insulate? I since learned how not to do that, but what did you use on the back of the T-shirt to insulate the wiring? Assuming 3-ply thread.
Yeah, so I had another white T-shirt that I just kind of sandwiched the LED strips between. So the LED strips are kind of coated with some hot glue to diffuse it a little bit of diffusion material, and then a white shirt underneath to actually protect my protect the wires from my body, because that would get annoying during the night.
Yeah. There was this one time I did a keynote in Malaysia, and it's a bit hot there, and the wires weren't insulated. Anyway, it was 5 volts. It was fine.
Don't try that at home, kids.
Don't. I don't recommend that. I mean, it keeps you sprightly on stage, but I don't recommend it. We do have a couple other questions too. This time about Sumobots. From Timothy, was there an RF to connect to external things, or was it all the logic self-contained on the actual device?
So we had it all contained on the device as well, so that we weren't getting any telemetry or anything back from it. It was basically just press the button and then it would think about and do everything. Again, partially because we wanted to keep it simple. Once you bring in the kind of wireless connections, it does raise it just a little bit more. So it's not so much with the IoT. It's all kind of on board, but all the logic was built in. Yeah.
The other one is, that makes sense too. And also the time transfer would be like you got a response, and do the wheels on the actual devices have to stay on the board, or can they kind of retract up and just kind of brick itself to the ground?
Yeah, so one of the rules was that you had to have the robot move without just being pushed from the other person. So if it didn't move for 5 seconds, then it would be out. So we had some people trying to think of that. Maybe we could get like a drone motor with propeller and really suck itself down to the ground. But the rules were brought in where we couldn't do that for kind of, it's more entertainment reasons, I reckon. It's more fun actually seeing them go out.
Yeah. Well, that was my other thought too, is you could just put legs and have it like stand there until it got pushed over.
Honestly,
or something.
If people can make one with legs, we probably would have allowed it. It just probably wouldn't have done that well.
And it still has to be under a kilo. Yeah, it's an interesting challenge.
Yeah.
That's so epic.
Yeah, that's so cool. I always love seeing the designs come up for the Sumobot challenges. It's always great. Those professional ones are insane.
I also really want to try the flag robot, the one where it flicks the flags out to try to like almost like a bull, where they've got the capes and the bull comes through and misses. If you can have those flags coming out, it'd be pretty cool to see. So that's what this guy is doing here. He's trying to trick that other robot to just go and go for the flag and then fall off the edge. Doesn't always work out, but
also it looked like a fancy one of those bird mating dances almost, where it's like
it does a little bit of a dance around. It did win that one actually, but
thank you. That was ace.
Thank you, Luke.
All good. Thank you guys as well.
Keen to get back into Makerspaces when we have the chance, and hackathons and all these sort of things.
Me too. Don't worry. As soon as it's open.
And we'll keep Luke around, and you can jump in the chat and ask him any questions if you have any things later. But we're going to jump to our next speaker now. We've got Army joining us, and you're already up on stage, which is fantastic. This is a nice little bit of a segue as well, because Army, when you were back at uni and just out of uni, Army was the RoboGals CEO for 3 years. So nice little segue from uni and beyond. So beyond uni, Army actually works at Telstra. And so we met when we were both working on the Telstra developer team together. So that's the API and IoT marketplace for Telstra. But now she's a senior solution architect focusing on IoT and cloud. And before that as well, Army's been doing lots of things with customer co-creation and innovation. And like us, I guess, like very passionate about new ideas and solutions. So that's why we've got Army along to speak to us today. It goes without saying, she's a fantastic advocate and fantastic role model for all IoT people, but she's a specifically strong advocate for promoting diversity and inclusion in engineering and STEM, which is something close to all of our hearts, I guess. And Army's talk today, Steve, you can jump to the next slide. It's the 3 Ds, and not developer, developer, developer. It is diversity, development, and disruption, specifically for the product development journey in the Internet of Things, and just for tech in general, I guess, for making sure that things aren't just working really well and are really cool, but they're also adding real value. So that's enough from me, Avi. I think I will hand it over to you now. Thank you for joining us. All the way
Thanks, Michelle.
from Melbourne.
Thanks, Michelle.
Thank you.
Yeah, and saw your note as well, Ali, about how we met at uni as Google student ambassadors. And actually, I met Dev Steve as well when I did my first hackathon. So definitely isn't a small world.
So cool.
I'll just
We're going to jump off the stage now, so you can share. And then while Ami's presenting, feel free to leave questions in the Q&A, and Developer Steve and I will come back on in about half an hour or 20, 25 minutes or so. All right.
Cool. Sounds good.
Thank you.
Thanks. I was just going to say as well, like it's pretty interesting talk from you, Luke. It totally brings me back to my uni days and how we had to build a robot. I think it was meant to be one that was fighting another one as well, but then because of all the vandalism and, you know, intense fights, they ended up changing the rules so that we were just scanning a color map of these discs, and then we had to stack those discs in that order using the robot. But fun times, lots of late nights, and definitely makes me want to go back. But anyway, so tonight I want to talk about a topic that I feel really passionately about, which is design thinking. And I'll do this by reflecting on a 10-week project that I worked on while studying. But before that, a really quick intro of myself. So I studied electrical and computer systems engineering from Monash University, and I currently work at Telstra as a senior architect in the IoT and cloud space. I've had a number of roles in the past. I've been a product owner, a customer engineer, and a solution owner. And I spent about 4 years working in IoT. So if you want to learn more about IoT and what Telstra is doing in this space, then feel free to check out this link. Sorry, I'm just recovering from a sore throat. So there'll be a bit of coughing. But I've also previously spent 3 years as the CEO of RoboGirls Global, which is an international not-for-profit organization that aims to get more young females interested in engineering and STEM. And so RoboGirls has chapters at universities all around the world. They go out to high schools and primary schools and run engineering workshops. And they also partner with corporates and with the government to help introduce more STEM into the curriculum and also reach a wider student base, including those in rural areas. And we also use mainly Lego Mindstorm robots, but I know we've also been doing a bit of work with Sumobots and some of the competitions. So good segue. But if you want to learn more about some of the great work that RoboGirls does, or even possibly get involved, then you can check out this link. And when I'm not doing all of that, I do like to spend my time cooking and baking. I've been doing this for quite a while, since I was in grade 2, actually, but perhaps a little bit too much during lockdown. So here are some dishes and some cakes that I've made recently. My friends would probably say that my signature dish is butter chicken, which is down here in the right-hand corner. My background is Indian and I am Punjabi, so I definitely take pride in my ability to cook good butter chicken. So that's a little bit about me. Now, before I start talking about design thinking, let's do a fun little exercise together. So in a minute or so, I'll ask you all to close your eyes and focus on picturing what I'm asking you to think of in your head. It's really easy. It's not difficult at all, so don't overthink it, okay? All right, we'll get started. So I want you all to close your eyes for a moment and think of a vase. And I can't actually see anyone, so I'm really hoping your eyes are closed. But picture a vase in your mind. You know, you could think about what shape it is. You could think about what the surface looks like, what color it is. Is it just hanging there in the middle of nothing, or is it standing on a table? Okay, now completely forget about the vase. Keep your eyes closed and think of a loved one. Think about how they could experience flowers. So in your mind, picture your loved one and how you would like them to experience flowers. Okay, you can open your eyes now. In the second scenario, when you were picturing your loved one, how many of you pictured the vase to? I'm guessing not a lot of you. In fact, most people don't think about the vase either. The first time that I thought about this, I thought about my grandma with her gardening gloves in the garden on a bright sunny day, planting some flowers. It looks something like this, although a lot more vivid in my mind. So the vase is only one of many ways to experience flowers. It's one of many possible solutions. So the point that I'm trying to make here is that often we'll go straight into solution mode when we're thinking of building a product, but what we should be doing is thinking about the experience that we'd like someone to have when using a product. This is known as design thinking. It's about human-centered design and designing for experience. Having worked in the product development space, I picked up a number of methodologies and frameworks, and one that really stood out to me was design thinking. It's a methodology that's used to solve problems and find solutions for customers. And this methodology is more like a mindset. It really focuses on drawing out the customer experience to help define the problem and then find a solution. Keeping in mind, of course, the customer and creating their desired future every step of the way. Design thinking leverages logic, imagination, intuition, and systematic reasoning to explore possibilities of what could be and to create those desired outcomes that benefit our end users. So a little bit of theory on design thinking. There are 5 main phases. First, it's empathize with your users, define your users' needs, their problem, and your insights. Ideate by challenging assumptions and brainstorming ideas for potential solutions. Prototype by actually creating these solutions, and then finally test your solution with your intended customers. So these 5 phases don't always have to follow a particular order. You can do some of these in parallel and repeat some steps, over like a few times to help inform on some of the other stages. But the idea is to co-create with your intended users or your customers by iteratively prototyping and getting their feedback until you perfect the solution. And this way, we know that there's a use for the product that we're building. So why is design thinking really important? Let's imagine for a moment that we've spent some time researching and playing around with some really great tech. We now found a way that we can commercialize this and productize it and sell it. And so we go away, we write a detailed business case, and we manage to get it funded. And then we start building the product. And let's just say it takes a year to build. And when we're finally ready to launch, we find that the product doesn't sell. And in the meantime, another product has come out that makes our technology obsolete. Some of you might have come across the Ford Edsel, although perhaps you didn't because it wasn't very popular. It's a classic design disaster. So the company actually spent more than $250 million over 10 years, in addition to a year-long advertising campaign that was heavily funded. And in the end, the product didn't sell. So the Ford Motor Company wanted to release a mid-sized car to cater for those who are upgrading their cars from the lower end of the market to the mid-range. And instead of studying their users or their customers, the company studied competitor products to gather their data. So they began styling their car in 1955, but by the time they launched 2 years later, in 1957, consumers were already looking for smaller, more fuel-efficient cars, and those were 2 things that the Edsel wasn't. So the design thinking process essentially helps us avoid making the mistake where we think we know what customers need without even asking them or having a single conversation with them. And we go away and spend time and money building a product that ends up not being useful and can't sell. By continuously getting your customers' feedback throughout the product development process, you're ensuring that your product roadmap is evolving as you build, and you can also account for changes in the customer's environment and also in the broader market. So you're not stuck building something that may be rendered obsolete. The key to doing all of this is empathizing with our customers, and that is the first step of the design thinking process. So this is when you really want to put yourself in their shoes and try to understand what it's like to be them. In my experience, the best way of doing this is by interviewing them and listening to what they have to say. And usually when you go into a customer interview, you'll generally have some idea of what their problems might be. You might have a rough outline of a solution, but I find that the best way to understand your customer is by going in with a completely blank canvas. And this way, you're not allowing your preconceptions to guide the conversation, you're allowing the customer to guide you. So take all your assumptions, throw them out the window, and just really listen and observe when you're talking to your customer. So as an example, if your target customer is a nurse, the types of questions that you want to be asking is how do they spend their time? What are their priorities? How long do their shifts last? What sort of tools do they use to perform their job? In customer interviews, we're generally looking for 3 main types of information. And in design thinking, often you use the analogy of a rose to explain this. So the first is the actual rose, the flower itself. These are the positives. You know, what's working well? What is the customer good at? The second are thorns. These are the negatives. What isn't working so well? These represent challenges and risks, and they're represented by thorns because they have the potential to hurt us. And finally, you have buds, and they represent potential and opportunities. So if these are taken care of properly, then they can grow to become roses. In my second year of university in 2014, I worked with a team to develop a solution to help improve the public transport experience. At the time, most of us were public transport users, so we could always count on our own experience, but we also interviewed a number of other users. And we did this by circulating online surveys. We went to stations and we spoke to commuters. We asked them about their journey. We asked them what their frustrations were, and we asked them what things that they'd like to see change. We also interviewed public transport authorities. They were our primary customer. And soon enough, in doing this, we found that our blank canvas had started to fill up with roses, thorns, and buds. So from all of this, we uncovered a number of insights. But the one key insight that we found out was that if people knew how full public transport vehicles were, then commuters would feel less anxious and have an overall improved public transport experience. And public transport authorities would be able to target their services more efficiently. And this leads me to the second stage of design thinking, which is the define stage. And just like we did, this involves uncovering insights and drawing out problem statements. So by the end of this phase, you're left with a number of insights and correlating problem statements, and now you want to prioritize them. And the person or the group of people to help you prioritize them, of course, is your customer. So go to your customers and your intended users and ask them, you know, does this insight seem correct to you? Is this statement valid? Is this actually a problem that you need to solve? And if so, how desperately do you need it to be solved? So from this, we can define what our customers' needs are, and also specifically what problem we're trying to solve. So once we've defined our problem statement, we now need to come up with a solution. And in order to do that, we need to ideate, which is the third stage in the design thinking process. So notice how so far we've spent a lot of time, you know, talking to the customer and understanding the customer's pain points, articulating their problem statement well, and now going into finding a solution. And we're not actually just starting off with a solution right from the start. So this particular phase is one of the most exciting because there's an opportunity here to explore your creative and your innovative side. In my personal experience, being an engineer and working in the technology industry, most of the solutions I've ideated with customers are technology-based solutions. And that's pretty normal, I'm guessing, for all of you as well. But keep in mind that your solutions don't have to always use the latest and greatest technology. It's about understanding how you can best serve the customer with technology. So something that I see quite often is people falling into the trap of trying to find a problem that can be solved using a specific, very specific technology that they've developed or they've come across. And it doesn't make sense to me. It's like picking out a screwdriver from your mailbox and then going into your house and saying, what can I fix with this particular screwdriver? It just doesn't make sense, right? So the lesson I've learnt from this is that it's more effective to define the problem and then look at your suite of technology tools to find the right technology that makes the most sense to use. Now, if I go back to the example of the public transport project that I was working on, our problem statement was to find a way to measure how full public transport vehicles were in near real time and inform users of this. In our process of ideation, we explored a number of methods to do this. We looked at using infrared cameras, facial recognition, sensors in seats, and Wi-Fi triangulation, along with quite a few other methods as well. But to determine which solution would fit the best, we actually used information that we had gathered from our first 2 stages. And so while interviewing our primary customer, we learned that they were in the process of implementing weight sensors in their vehicles at the time. And we thought, why don't we leverage this to solve our problem? At the time, it was the most cost-effective solution. It was the least disruptive to transport services, and it also provided a level of accuracy that was acceptable by our customers. But when we actually presented this to our primary customer, they told us that they were not looking to use this solution because the weight sensors were not really intended for this purpose, because we needed readings that were a lot more frequent than what they had originally planned for. And this is actually something that happens quite often, I found. You get comments like, that's not how we normally do it. Our users won't be able to use this technology, or this wasn't intended for this purpose. And generally, this is people sort of being a bit reluctant to change things because they just don't know what the outcome will be like. And I think it's really important where, we have an opportunity here to start challenging some of these assumptions and actually shift their mindset and disrupt their way of working and thinking. So having those awkward and uncomfortable conversations isn't always a bad thing. It means that disruption is underway, and it means that we're thinking outside of the box from a new perspective. So it's okay sometimes to push back when you get pushback. So after ideating our solution, we ended up coming up with a solution that used weight sensors to measure vehicle capacity, and also using a mobile phone application to inform users of this. And so this slide shows a very, very, very high level overview of the key components of the solution. And in a sec as well, I'll show you the prototype where you'll see some of these components as well. So let's just take a moment to reflect over the 3 stages so far. We started off by talking to customers and users and getting their feedback, understanding their frustrations, and also exploring, potential and opportunities. We then formed insights based on this feedback. These insights helped us define the problem and what our customers' needs were. And we then took this problem through an ideation phase where we pulled it apart and explored a number of solutions before picking the solution that fits the best. So we started really broad, and we continued to refine and define as we progressed through the stages. The final 2 stages of the design thinking process are prototyping and testing. And these 2 stages go hand in hand. Prototyping is all about bringing your solution to life and actually building it. And in design thinking, testing isn't just referring to seeing if your technology is functional. It's about actually getting a prototype into your customer's hands and having them use it. So it's about testing for user experience, and the things that you should be looking at during this phase is how intuitive the product is and how much you have to help the customer navigate it, or how easily they could navigate it, and if it's even comfortable for them to use it. So all of this feedback is really valuable in informing and improving your prototype. So I guess that's how you iteratively prototype and test with your customer until you reach an MVP, where you can continue to develop after that more features and incorporate them in future releases and so forth. So for our public transport solution, prototyping was a bit challenging. Getting access to a public transport vehicle isn't always readily available, but we did prototype and test we did prototype and test using this train model. So we laser cut and 3D printed the train model, the train body, and then we used kitchen scales as weight sensors. And then we also used bolts to represent passengers onboarding and getting off the train. We also ended up using an Arduino and a Raspberry Pi. So I think we could have probably done with just the Arduino itself, but I think part of the challenge requirements were for this particular project that we had to use a Raspberry Pi. So sort of made it work in that sense. But yeah, we were able to collect this data, crunch the numbers, and show how full the train was in somewhat real time. And we built a dummy mobile phone application as well that sort of showed that information, and it would update every 20 seconds. So I guess the advantage of iteratively prototyping and testing before releasing the entire product is the feedback and the validation that you get from customers. It reduces the risk of spending large chunks of money to build a product that isn't required and might not sell, but instead you can actually spend smaller chunks of money on features and validate them as you continue to develop. So that in 15 or 20 minutes is how you can develop products using the design thinking process. You might have noticed that the customer is involved in all 5 stages of the design thinking process, and it's probably the word I've said the most in this presentation. They're really critical to the entire process, and because they're so important, it's quite important as well for you to define how you intend on collaborating with them. So typically when I followed this framework, we've worked in an agile way. We've worked in 9-day sprints, and at the end of every sprint, our work delivers value to our customers. We engage with them at least once every sprint, sometimes more. But because we've set up this cadence and this way of working, we're able to incorporate their feedback and their validation to help refine our product as we build it. I also wanted to include this picture of my team who I worked with on the public transport solution. And so even though we didn't prototype and test our solution with our primary customer, we were able to show them a demonstration just as a proof of concept. And we ended up submitting this idea into the Telstra M2M University Challenge in 2014. And for that year, this ended up winning. So that was super exciting. And you can see a big fat check for 10K as well that we won. But one thing that I wanted to highlight was just the diversity that we had in this team. It goes without saying, having diverse teams leads to more perspectives and enables innovation and ingenuity. This particular team was multidisciplinary. We had students from engineering, business, IT, science, and industrial design and architecture. And we also had students who were in their first year and others who were in their 5th year. So a lot of, I guess, diversity in skills and experience. And I think that's really what made us a strong team that was able to go and win this competition. But for me as well, that was a really big eye-opener, because that's how, I guess, companies actually build products. You need hustlers and hackers and hipsters and people with, diverse skills to build some great products that customers are using today. So this was one competition that I did in my 2nd year, but throughout my time at university, starting actually from my 1st year, I participated in a lot of similar competitions with different companies. And one of them was a global competition that was organized by Shell. So for this, we had to come up with an idea to solve food, water, or energy problems in the world. And my team decided to tackle water issues, particularly to do with water sustainability and education. Our idea was called Smart Water, and it had 2 main components: water meter sensors that were installed at each tap in the house, and a mobile phone application that was able to track water usage at each of those locations, analyze the trends, and then suggest improvements on how to save water. So we, I guess, started off with ideation, and we finalized some of the core components. We looked at our target users and our use cases, and then started building out a business case, looking at a production plan and a go-to-market strategy, and whatever you would do for a business case. At the same time, we also started prototyping our idea. Again, we ended up using an Arduino for this as well, and used a water measuring sensor that we attached on a tap to sort of to validate our proof of concept. So our idea ended up getting selected for the World Finals, and we were the only team from the Southern Hemisphere actually that had made it to this point in the competition. And we were flown to the Netherlands, where we pitched our idea in front of hundreds of people from all across the world. Super daunting experience, but it was still a great experience. And that was actually my first pitch and my first competition. So I was definitely extra nervous. But even though we didn't win this competition, we didn't really and even though we didn't follow the design thinking process to a T, this was actually the first time that I'd been able to experience engineering in its application. And it's how I grew my interest in product development and also in IoT. And when I think about it now, a lot of the projects that I did whilst at university, a lot of them revolved around IoT before I even knew what IoT was. So even my final year project, I ended up doing smart jewelry. So I ended up making a smart necklace that you could control from your mobile phone. But I guess when we talk about pathways into IoT, for me, it was more about working on projects in the area and then continuing to build my interest and knowledge in the space. And that's kind of how I ended up working in IoT. But these days, there's a lot of different, there's a lot of different customer and technology trends, and a lot of those are also becoming intertwined. IoT touches so many industries like healthcare and logistics and agriculture and so many more. So even if you aren't working in IoT directly, chances are that you will come across it at some point. Anyway, that's it from me. I think I finished on time. So I hope you all gained some insight on how the design thinking process can be applied to develop, I guess, products and also products in IoT.
Yeah, your timing couldn't have been better, literally. That was perfect. You've obviously done this before. Thank you, Almi. I love that. And I love when you showed that picture of your team that won the big $10,000 check at the M2M showcase. I was like, oh, this is going to be an example of like not good diversity. Like Almi's the only, like visible female we can see in the group. But it was a really good call out that diversity isn't just what you can see. Diversity is also in your experience, in your discipline, in things like your age and what level of university you're at and things like that. So that's a really good call out as well. We do have a couple of questions in the chat, actually. So there's a few questions on food. I'm going to go to the fun ones first. People are obviously very impressed that you have a side hustle with food. I reckon you should promote that by posting your links in the chat later if you want to get on that, especially people in Melbourne. But there's a question in there that I kind of want to ask you. How do you think IoT is used in the food industry? Which is a bit out there, but any part of food.
Yeah, I think IoT is definitely used in the food industry. The easiest example that I can think of is essentially like paddock to plate, right? A lot of people, or a lot of farmers rather, can benefit from using IoT when it comes to making sure that their produce is, being transported in the right conditions and being able to sort of track it to make sure that it's coming to warehouses and the supermarkets and coming to us on time. So that's probably like the go-to example that I can think of. But I guess another, not that this is food related per se, but it's still to do with eating. I read an article a couple of months ago, I think, about how you can ingest these sensors, like these micro sensors, and they essentially tell you if you've taken your medicine or not. So it's meant to be for people who suffer from memory issues, possibly people who have dementia, who are a bit older, and they don't always remember or know if they've taken their pills or not. So that's also something that I guess I read about, and I don't know where it is in terms of its development journey. I imagine it would have to go through a lot of testing and making sure it's all safe, but that's also pretty cool.
I totally did not expect you to go there when I said IoT for food, but this is so funny because it's exactly what I thought of at the start of I think when developer Steve was talking about ESP32s before, he's like, they're literally like candy. And I was like, no, not candy, don't eat them. But then it made me think, I actually have a friend who had some like unidentifiable health issues, and they actually gave her a camera, and she like ate a camera or something that actually did what it needed to do and told them what they needed to do, and then dissolved. Like, yeah, crazy.
Yeah.
So there is like ingestible IoT things in healthcare. And you mentioned healthcare as one of the growing like IoT industries, or something I don't usually think of. Like at the moment, ag tech for me is the thing that I default to. Like we had an ag tech themed AusIOT Meetup a few months ago, and there's a lot of interest in this community with ag tech. But health tech is something we haven't really thought about yet. Developers, have you got any cool health tech use cases? Health IoT?
I mean, the only thing I had come to mind, and we totally need to get him to come on and do a talk, is our good friend Meow Meow, he was the person that embedded the Opal card into his hand. Yeah, and then that was in the media for a few weeks. But like I've literally seen, and again from hackathons, like and developer Ali will know what I'm about to say, but from that. Meow Meow came out of Hackagong in Wollongong back in the day, and they were actually embedding LEDs in under their skin as well, sometimes without anesthetic, which is interesting. But anyway, big fan as well, and always love seeing just how it can help people, because as a tech enthusiast, that's what it's about. So yeah. Big fan.
I think another big application. Sorry.
You go.
Okay, I was just going to say another application in healthcare is just with wearables, particularly like your active wear and things like that. So they're these little, like, I guess, sensors that are put into certain types of clothing that can monitor, like, your heart rate and your general like health parameters when you're, say, going on a hike or going somewhere that's a bit risky. If you are someone who's at risk, and then in the case where they can't detect information over, like, say, 2 minutes or something, then they actually call emergency services. And when I saw the use case for that as well, they had like a helicopter flying over that was rescuing someone from the top of a mountain, and I thought that was pretty cool that your clothes can do that. So
not like a watch or something, but they're actual clothes. Yeah,
they're actually clothes. Yeah.
You guys have had so many segues between your and Luke's like conversations now with these like IoT shirts. That is cool. So there's actually a specific question here, which I'm pretty sure is about the trained IoT example you had. So this question: did you use a broker to pass weight info from the device to the server? And this was a few years ago, so I don't know if you remember exactly how it worked.
It was like 6 years ago. I don't remember exactly how it worked, which is why I didn't actually go into it in too much detail. But yeah, I'm going to say yes.
Yeah, probably, right?
Yeah.
So this is actually following on from that. So this was 6 years ago. This was like when you were back at uni. So this question is, where do you recommend someone get started if they want to work in the IoT industry? So I think it was funny that you were saying that you'd worked in IoT a lot before you even know what IoT was. You didn't call it IoT. It was just doing some like fun hacks and stuff. So yeah, what's your recommendation there?
I think kind of like what Luke was talking about as well, getting started with Arduino and getting started with Sumobots or things like that. Sumobots is, I guess, a bit more fun, but like Arduino is a great place to start. I think any small sort of like microcontroller that you can use to control like anything, like a device or a light or something like that, that's a really great place to start. I think there's a lot of like IoT can literally be used anywhere. So if you want to build your interest and your sort of knowledge in it, I think the best way is just by actually, applying yourself and doing things. And then at the same time, if you want to start doing it a bit more like officially, you could always do hackathons or competitions as well to get more of an idea of it. I found it was really useful, I guess, when I was doing these competitions at uni, I found it was really useful to work on the business case and the business side of things, as well as like some of the technology and prototyping. That for me actually really helped me understand the market and the industry. And I am someone who's a bit more interested in, the customer experience and the market like as well. So I think that was like a really great way for me to just learn about the industry and kind of work on some projects where I built enough in my portfolio to say, oh, I know about IoT and I see myself working here.
So if you were either a hustler, a hipster, or a hacker, you'd probably be like on the hustler side then?
Hustler,
yeah. No, me too. Developer Steve, you're definitely a hacker.
I'm dressed like it at the moment, right? No, that's the thing. I think I've always liked too is particularly with IoT stuff. It's like you look at something and go, "Oh wow, can put some lights in that and make it like light up and stuff." And, control it through Wi-Fi or control it through the SMS gateway, whatever it is. Which I did do one time. Oh, actually, Michelle, we did that demo last year too with the fall sensor. Remember?
Yeah. Like integrating. Yeah, the Arduino device to trigger an SMS when acceleration was past a certain point. A lot of maths involved in that.
Yeah, there was. Remember we were trying to calibrate the thing? But yeah, the code for that's on GitHub too, if anyone wants to check that out. It's just using Node-RED, which is super easy to build out prototype things too.
Actually, before we started this call, Developer Steve, you were worried about all of your light sensors in your house, right? You have a lot of IoT things at home. Like you got a lot of IoT stuff going on. Is everything all right now after your Wi-Fi went out?
Yeah, the internet dropped, and of course none of my smart devices worked, so can't turn the lights on and off and stuff like that.
See, that's a limitation, right? Like in IoT as well, when things go south, does that mean you can't control them? Or if things go offline or if something gets hacked, then as well, does that mean other people are controlling them? So
yeah,
we had the other week, last meetup, we had SA Water come and talk about their like really critical Internet of Things like energy systems, and it's like you don't want those things over the internet. They're still IoT, but they're not like
disconnected.
Vulnerable.
Which I mean, for water, I totally approve. We need that.
Speaking of things that are very secure and connected, Army, there's a question here for you. This is an opinion. Like, what's your opinion on blockchain and the Internet of Things?
That's a good question. Well, I think there's definitely some use cases that would be valid. A lot of these technology trends are becoming more and more intertwined. So I think the biggest thing that I can see is potentially from like a security perspective and a fraud identification perspective. There's a lot of data, I guess, that's in question, and being able to make sure that the location of the data that's being accessed and everything, and also I guess who's accessing that data and everything. I think there's a bit of scope there that we can improve on, but I think this is something I have to think about a bit more. I haven't actually thought about blockchain too much.
No, but that's why I asked. It was so cool that it came up, and it comes back to the first question that you answered about like paddock to plate, right? And the sovereignty of the data you mentioned, like how do you make sure that it was from the right person? It makes me think about, I'm pretty sure this was you that said this, but on your podcast interview with Engineers Australia, there was a quote that stuck with me that was like, there's almost as many cows connected to the internet as people, or maybe even more, right? Isn't that crazy? Like there's, we all have a mobile phone, but there's actually all these devices and things out there in the supply chains that are connected.
Yeah.
There is more questions. You've got more questions coming through. What is one of the fields you think is growing the most in the Internet of Things? We've already mentioned a few, so any other ones you think?
Yeah, I think agri-tech is definitely the one that's front of mind, I guess, at the moment for us as well. Healthcare, definitely. I think agri-tech and healthcare are probably the two biggest IoT ones, but that's from like an enterprise business sort of perspective. If you think about it from a consumer space, I think there's just a lot of, there's like a huge shift towards automating things and being able to do things from your mobile phone without actually having to get up. So even like something like a smart home, for example, where you can control lights, but also potentially like, I don't know, cook your dinner before you get home, if that's possible and safe. But there's definitely like more work that's being done in making homes smarter and making just general like how we use and interact with our environment, just making those general interactions more automated and IoT integrated.
Yeah, definitely. And I'll just call out in the chat, Trent actually mentioned a while ago, IoT and supply chain is another big thing too. And it all comes back to agri-tech, I reckon. But yeah, no, supply chain and tracking is a big one too.
Special mention too to home automation, like IoT kettles, amazing. Like it can be boiled by the time you get out of bed. It's great.
Wait, how does it work? Like, this is my thing with these smart home things, right? Like I remember my old boss told me like, oh, Michelle, get us like a smart coffee machine so that I can like get the robot to make my coffee. But like I could get them a smart plug that would turn the coffee machine on, but it wouldn't like grind the beans and then do all that. Like, does a smart kettle actually turn on and then start boiling?
No, those are really expensive. I looked at those.
Okay.
No, this literally just boils the kettle.
But like you'd have to have kettle set to like trigger it on to boil and then have it turned off at the power point, and then the IoT switch would turn the power point on and it would start boiling.
Originally yes, but now they just like it's just got Wi-Fi built in. So and they're like $50 from, I'm gonna mention Kogan, but they're literally a rebranded 2-year kettle. Yeah, it's pretty much just on and off, and I think you can set the temperature, but yeah.
You know what would be really good though? Smart fridges that would tell you what's in your fridge and make a shopping list on its own, and then also suggest recipes for you to make based on what you have.
Yeah. I had a Samsung smart fridge, like the family hub fridge in one of my old offices, back at the 5G Innovation Center, and we had all this cool tech. And it was pretty cool, actually. Like you could be at the shop and then be like, oh, do we have milk? And then you could go in and like see it. But I think as I worked on this at university as well, we did like a prototype for a smart fridge, but we couldn't figure out how you could actually scan everything. So like, yeah, there's one thing, you can have a camera there, but like you have to still physically go and look. Like, do you have to have an AI to actually see what's in there and make an inventory? Anyway, it's lots of space to grow there.
One thing that I was looking at as well for a potential final year project at uni was using carbon sensors, I guess, essentially to like figure out how ripe your fruit is and when's the optimum time to eat your fruit. So if it's like sitting there in a fruit tray, like bananas, for example, or like any fruit in general, it releases a certain gas. And then if you track the level of that gas, it's like you can find out, okay, it's now optimum to eat this banana, or don't eat this banana. It's, gone past the point of, although you could probably look at it and tell as well. But even something like that, like for food spoilage and, making sure that you don't have to throw things out. So
any of those things at scale makes so much sense. Like my partner runs a camping business from here, and like, if they have their fruit for more than a couple of days, then he needs to know, like, while he's in the office without having to go to the warehouse and like check the fruit. So that is really cool. I never heard of that.
We literally just processed 20 kilos of shaddix. It's kind of a cross between an orange and a grapefruit into jam because they were going off. Anyway,
I've never heard of that.
Farm things. They're really,
Farm
they're
life.
like 3 of them basically are 1.5 kilos each. So there was a lot of them. I cut up a lot of shaddix. I did have one last question, and this one is actually, something you said too, which is like it's really easy to pick up and prototype IoT stuff now and build something out. This one time, I actually connected the top of my wedding cake to, I used the Telstra the SMS API so that the guests could change the color of the top of the cake. And I did it the night before because, that's when you do all your best demos, right? But have you thought about combining IoT and pastry goods to make interactive food?
I don't think I thought about it in that sense, but that would be pretty cool, actually. If you have like, you can program a message or something on top of the cake, or even like potentially the cake changes color depending on the freshness of it, or I don't know.
That's a good
like
one.
There's tracking as well, which is pretty general, but I think at the moment we kind of do have general tracking as well. But yeah.
You heard it first, guys. Army's pivoting into an IoT cake
IoT cake. IoT edibles.
Oh gosh. Well, on that note, we probably can leave it out there to leave 13 minutes for networking on the tables. But Army, thank you so much for coming down today, coming onto the ether in our IoT meetup. And thank you to Luke as well. That was a really fun, fresh, lively set of speakers tonight. I think I got really excited listening to both of you guys. And yeah, thank you to everyone else who's also still stuck around listening as well. We will hang around for another few minutes to network on the tables. Steve, we've explained how Remo works, right? Like how.
Yeah, you just click around, jump around the tables. You can't flip them though, which is a good thing because we don't do that. But anyway, yeah, you can jump around the tables and be able to network and talk to each other. So next event, just quickly, will be in October. I don't think we've set a date for it yet, but it'll be around probably the end. But stay tuned for next dates. And I think, wait, should we talk about what the next one will be?
Yeah, talk about what you want to do. Maybe someone here will have some ideas.
So the next one, I don't know if anyone's familiar with the ETSI security standards that the federal government's looking at bringing in. I think we might have talked about it in one of the previous meetups, but we're essentially looking to get a panel together to talk about what the ETSI security standards mean to consumer and commercial devices. So, and essentially this is going to affect things like a $50 kettle, for example, where it'll now have to meet certain criteria to, well, be sold here. Which is kind of good because, I mean, it keeps it safe and keeps things all nice and secure so that no one gets in and messes with your light bulbs and kettles. So, but yeah, anyway, we're looking to put together a panel to talk about what it means just for the hobbyist and right through to commercialization.
So if you're interested or you know someone who is a little bit of an expert on ETSI or ETSI standards, then let us know in the Discord. And if you guys have if you have any events that you want to talk about too, I think there was an Orange IoT meetup just a few weeks ago. I don't know how often you guys have those, but yeah, let us know if there's any other events we should be talking about and promoting.
Awesome. Let's go back to tables and do some networking.
Yeah, go meet.